called isotopes. First off, an isotope is atoms that have the same number of protons, but they're going to have different numbers of neutrons. So, because it has the same number of protons, that means it's not changing the identity of the element, and it's also not changing the charge because the electron number is the same also. So you still have a neutrally charged atom. Now we just have a different number of neutrons, so that means the only thing that changes is the mass of that atom, because now you've got a different number of particles, so it's going to slightly change the mass. Some things about the properties of isotopes. Each element has a limited number of isotopes that are found in nature. So there's not a limitless amount. You know, we can't have neon one that has 9 electrons, one that has 20, or sorry, excuse me, 9 neutrons, one that has 20 neutrons, one that has 100 neutrons. It's definitely limited. Some have more naturally occurring isotopes than others. But either way, some of our isotopes are going to, they may have special properties because of that unbalance of neutrons. So the unbalance of neutrons can make them unstable. If you have an atom that is unstable, that means that the nucleus is going to change over time, and just you know, it could happen more quickly or slowly depending on which element you're talking about. But if that's the case, that would make that element radioactive. So if an atom is breaking down, that makes that atom unstable and that makes it radioactive. For the most part, the isotopes of all the isotopes of an element share pretty much all the same chemical and physical properties. Obviously, I just said some could be unstable, but there are definitely some that are, or most of them are going to be sharing the same properties as the fellow isotopes of that element. Okay, so we're going to have a few calculations here we're going to do. So this is some of the first math we're really doing. It's nothing too complicated, but the first thing is the mass number. So you can identify an isotope by the element of an element by the mass number. All you have to do is find the sum of the protons and neutrons in the atom. So if you have an element that has, let's say we have neon, which has 10 protons, and there's an isotope that has of neon that has 11 neutrons, you just take 10 plus 11, and its mass number would be 21. So it's not very difficult. All you got to do is add protons and neutrons together. Now when we name our isotopes, we use our mass numbers. So we use the skill that we just got. So all you have to do is to write the name of the name of the element that you have, write a hyphen after it, and then write its mass number after. So if I say that a carbon atom with 6 protons and 6 neutrons, which all carbon atoms have 6 protons, so I'm not necessarily going to tell you what the element is. I may just tell you what the element is, or I may tell you just the number of protons. Either way, you should be able to find out either how many protons or what the element name is, because that's how you identify an element in general, is by its atomic number. But you know that it's carbon, and you know it has 6 protons and 6 neutrons. So to find the mass number, you just add them together. So 6 plus 6 is 12. So you would write this isotope's name as carbon-12, and that's all you have to do. The atomic mass is a little more complicated, but it's nothing too crazy here. So all the atomic masses, which we talked about in our element block notes, is that it's the weighted average of all the isotopes of the element. So we have, there could be 2 or 3, there could be 5 different isotopes in an element. So they take each mass of those and get an average based on how prevalent they are in nature. So, for example here, copper has 2 different isotopes. Copper 63 makes up 69% of all the copper that's out there, and copper 65 makes up 31% of all the copper that's out there. So the way we solve this is by taking the percentage of its prevalence times its mass number for each isotope that we have. So if you look down in the bottom left corner, I have 63, which is the mass number of copper 63, times 0.69, that comes out to 43.47, and then 65 times 0.31, because copper 65 makes up 31% of all the isotopes, and that comes out to 20.15. So then to get the average, you just add those together. So when I add 43.47 plus 20.15, you get 63.6 AMU. So you may have 3 or 4 different isotopes. If that's the case, you just take their percentages times their mass number for all 4 of them, and then you add all 4 of those answers together. So it just depends on which element we're talking about for that.